Hi there. So today what I thought I'd do is play around a little bit of robot hacking or toy hacking. And I've got this cool old robot that, it's not really a robot, it's tethered, it's remote control, um, that I could hack and tear apart and make into some sort of autonomous vehicle. And I thought what I would do this time is keep it simple. I'm going to use just an Arduino Uno because it doesn't have to be fast or anything fancy, and they're pretty affordable, and I have a pile of them. And one of these motor controller boards, which will handle 4 DC motors, and this thing only has 3, so we're set and ready to go. And I think initially what I'm going to do is just make it run with a infrared remote control, and then once I've got that going, I can think about upgrading it and switching it over. Making it a little more sophisticated. So I'll have to figure out a way of mounting this on here. Maybe I'll mount it vertically, and then there's going to have to be a spot for some batteries, but we'll figure that out. And to show you what this old thing did, it's actually pretty cool. It just switches. These wires just run to the 3 motors, and this joystick, of course, runs this motor forward and backwards. This one does the same with this one, so I can drive forward and back. This one does nothing in the horizontal axis. This one drives this motor, which has a set of levers which will allow it to lower its tracks and rearrange its configuration a fair little bit, and it still then can drive around. Okay, so I think what I'm going to do initially is I'm just going to open this thing up and get the access to the wires. I might not even trim them yet. I might just make it go in my first iteration and then worry about making it neater and more compact as things go. So I'm going to pause this, take some things apart, and I'll show you as I go. So I'll see you here in a minute. So I've taken this apart and really haven't gained anything, to be honest with you. I thought maybe I might be able to get access to some wires a little easier. So I've decided I'm just going to go ahead and cut them. In fact, I'll cut it right now. And I'm going to leave a little bit because who knows, I might want to put something back together. I can't imagine why right now, but now I'll know where the wires go. At least can figure it out with the colors and give me at least a 50-50 chance of putting them together correctly again. So we've got these wires now. I'm going to chase them down, figure out which one goes to which motor, and then we're going to go ahead and hook it into this guy, and I'll bench test it first. So let me get this cleaned up, ready to go, and I'll show you what I do next. Give me a moment. Okay, so I've done a little wire chasing, and I found that this particular strand went all the way down, and this is, remember, there's 3 motors, and yet we have 2 of these bundles of 4, okay, which meant that one of these bundles wasn't doing anything. I don't need 8 wires, I only need 6 to run the 3 motors. And it turns out this one was easy. I followed it. The blue and the yellow are cut underneath the chassis, and only the red and the white go to the motor, and it goes to this motor that runs the left side of the drive mechanism. And I've taken and snapped these 2 boards together, and what I'm going to do is just to test it out, I'm actually going to run just this one motor to make sure everything kind of works, and I'm going to go ahead and put in the motor 1 controller. So let me get that attached, and we'll load up a little piece of code, and we'll see whether or not we can run just this one motor directly. So again, I'll be right back. Okay, so I've hooked up that motor to the motor 1 slot just by tightening it in. And I've whipped up a little bit of code. I have another video on this, but I'm going to give it a real quick rundown. I did have to include the library, okay, for this particular motor controller. I had to create the object. I'm using motor 1, so I had to actually create an object for motor 1. I've set the speed at 250. It can be anywhere from 200. Well, actually, I think it goes even lower. I don't know why I said 200 to 255, but you can set it. That sets the various speed maximum of 255. And then what I'm going to do is I'm going to run it. I'm going to set the speed at 200. And in fact, I'll just speed that up right now because it didn't do very well. And then I'm going to run it forward for 1 second, and then I'm going to run it backward for 1 second, and I'm going to release. And then I'm going to put it into an infinite loop. Okay, so it should just stop after doing 1 cycle. And I'll go ahead and load it up. And we'll give it a quick test. And that's exactly what I told it to do. Okay, really cool. So now what I'm going to go ahead and do is tap into these other 3 motors, build a little piece of test code, and I'll see you in a second. Okay, so I've done what I said I would. I went ahead and split these wires. You can see, and I now have 3 motors hooked in. So I have this motor here hooked up to this position here, the motor 1. I have motor 2 running this side, and I have motor 3 running here. Okay, and then in the code I just created 2 more. I just copy and pasted 2 more iterations of the same thing, changed the numbers, changed their motor value locations. In setup, I just initialized them all at the same relatively high speed, near the top at 255. And then I went ahead and ran the first motor forward and then backwards for a second. I will say the first time I hooked this up, I had the white and red wires flipped and it went reverse and then forward, so I had to unscrew it, rearrange the wires so that it went the right direction, so it went forward and then backwards. And notice I'm releasing the motors after every run. I don't have a battery pack yet hooked up, so everything is being powered off the USB, so I got to be careful. I don't want to suck down too much power. But if I run this, it should run all 3 motors in a test and then stop because it gets stuck in this infinite loop. And we'll run it right now, and it's going to run this motor, then this one, and then this one for 5 seconds. Brings it up and brings it down. So we're doing well. So now I'll go ahead and move into the next phase, and I'll see you in a second. Okay, so I've added quite a bit to the code just to make it a little easier to work with and build upon. And what I've done is I've broken it into functions. I have a forward function, backward function, a lift function, lower function, and a stop it function. And in each case, I have 2 arguments: the speed where the motor runs and how long it's going to do it. Okay, and you can see what happens is if I put a value into speed, it'll get carried down here and we'll set the speed, and then it'll turn the motors on and we'll get the delay for how long it stays on carried bound by this argument. So if I go up, for example, where forward is called in my loop, you can see I have a forward, backward, stop it, lift, lower, and stop it. So I'm going to run forward at maximum speed for 2 seconds, backwards at maximum speed for 2 seconds. I have to stop it because if I jump right into lift, it'll continue going backwards until I tell it to stop the motors. Stop it stops all the motors. Okay, so it makes it kind of convenient to switch. And then I'm going to lift it for 5 seconds, and then just to test it out, I'm going to make it run much slower at 100, the speed of 100 for 6 seconds. So we should see a big difference in speed. And I'll load it up, and we'll make sure we're going in the right direction here. We got our forward, our backward, our higher speed lift. Of course, it's fighting gravity, so it's probably a little slower there. And a nice, slow lowering. All right, so everything's going well. So let me move on to the next phase, and I'll see you in a second. Okay, so things are moving along. I did hook up this remote control, and what I did is I essentially copy and pasted the code that I have posted on my site. If you go to the pattonrobotics.com, and then you can go down to input-output devices, and I believe it's currently on page 3, and if you scroll down you'll find that remote, and then from here you can click on, well, there's a video about setting it all up which might be useful, but then you just click here and it takes you to a bunch of code that I've posted. All I really did was copy and paste all this code into my robot code, and we'll look at that right now. So you can see I've taken all the little bits and pieces, the RRA mode, I put in the strings and variables. I didn't change anything. The only thing that I did do is that the Arduino Uno is so slow that the numbers that it was getting in the from the IR were different than what it was with the Teensy, which is a much faster processor. I'm not exactly sure why that is, but they differed quite a bit. So I had to change these numbers, and those numbers actually derive from here. When I get the raw data from the IR transmitter, I actually displayed it first, and then what I did is I processed those numbers and compared them with this switch statement down here. So if it was, for example, a negative 11,233, then I knew it was a left. Okay, so as I push the buttons, get this on a field where you can kind of see it. As I push the buttons, you can see that the different buttons cause a different value to show up, and it's all working very, very well. And it should, if I hold it down, always remember what was the last one that I had hit. Okay, so let me go ahead and work with that, and I'll be right back. Okay, so I ran into a little bit of a snag, which took a little bit of time, but I figured it out, so I'll share that with you. Turns out the motor controller here and the code or the library that uses the infrared receiver both share the same timer by default. And unfortunately, we can't really rearrange the timers on this particular thing because they're physically tied into pins that are linked to those specific timers, and there's really no way to change them. But we can change the timer on this. Okay, and it's not that hard. It took a little while to figure it out, but it's not that hard. What you want to do is you want to go and you want to find the file that controls that, and it should be, if you have a relatively new version of Windows and Arduino, it'll be in your documents, and then from there you click on Arduino, and I've got a lot of junk here. But you want to scroll down to libraries, and in libraries you want to find the library that you installed to make this go, the Arduino IR Remote Master. And then what you want to do is you want to click on, you want to open up this board definition file. There's a lot of ways you can do it. In fact, actually, I'll just open it up with WordPad. Although I tend to use Notepad++, WordPad will work just fine. And what you want to do with this is you want to scroll down to the section, although I admit this is a little harder to see in black and white, but it works out okay. Here it is. Normally, this thing, when you get it first, it's going to be using timer 2. That's the one that conflicts with the motor controller board. So if you simply comment out this and then uncomment this, so now that we're going to use timer 1 instead of timer 2, and then save it, okay? So actually, when you open it up at first, it's going to look like this. Okay? I want you to switch that. I want you to use timer 1, okay? Save it, and once you've done that, you should be good to go. I'll save it. Okay? And now what I've done is I've taken that little piece of code that we were playing with before, and all I've done is add a couple of functions that we've already played with into it. So for example, if you hit a 1, it's going to lift this mechanism up. If you hit a 3, it's going to lower that mechanism. And if you hit the forward key, it's going to go forward. That sets the speed, and I'll show you that in a second. And if you hit reverse, it's going to go reverse. And this is also very important. If you hit the OK button, the center button in the control, okay, in my case, it's then going to stop it, which stops all the motors. And let's look quickly at those functional codes. Notice I put an F. Where did I put it? Here it is. Forward F, that means basically forward forever. If we look at my forward F, there's no delay. It just runs until you tell it to stop. Okay. Same with the backward. It's going to run until you tell it to stop. Okay. There's not going to be any delay here, but sets the speed, but runs until you tell it to stop. And that's how this is going to work. It's going to go until you tell it to stop. So if I do so, I've already loaded it up. You can see that I can run it backwards. This thing is getting stuck on some cable. Let me move that out of the way so we can actually see it. And then here's my lift. Notice every single time I'm actually telling it to stop. It goes until I tell it to stop. All right, I'm going to add a little bit more code to this, and I'll see you in a second. Okay, so I'm pretty happy with this. I'm going to end this video with this until I build some additional functions onto the physical chassis. So I've added left and right, and all I've done there is, of course, when you call the left, it'll call the left function. And the left function, I've added up here, the left and the right, here they are. And ultimately, it's pretty much the same thing. I just have one wheel going one way, one wheel going the other. So if I go ahead and get this guy going, it's forward, reverse, and then I can turn right, I can turn left, and of course I can bring down the axles, and all the functions continue to work just fine. Okay, so I'm going to wrap this up, and like I said, I think the next thing I'll do is work on finding a place to mount this board and battery, and I'll shoot that on another set. So I'll see you a little bit later. Bye.